Let us see some more examples. I'm taking all the examples from the book. Okay, so this is question number 4, example number 4 here, which is question number 20 from the book. Okay, so this is a linear first order linear differential equation because it can be written as y prime plus a function of t times y equals to another function of t. Okay, this is initial value problem because y at natural log of 2 is given as 0, which is given sorry, this should be 1. Y at natural log of 2 is given as 1. Okay, so we'll solve this problem. We don't have to draw the direction field for this one. So to solve this one, what we do first is divide by t, right? So if you divide by t, what do you get? Well, you get dy over dt plus t plus 1 over t. You see that? Equals to 1. This is what you get, right? T plus 1 over t equals to 1. So what we need to do is we need to find out the integrating factor next. Equals to e to the, oh sorry, y is there. E to the, you get integral of p dt. What is p? P is e to the integral t plus 1 over t, right? And then this is dt. So what do you get? You get e to the integral t over t is 1 plus 1 over t, right? Dt. Now find out the integral of that. It is e to the t plus natural log of t. That's what you get, right? So it can be written as e to the t times e to the natural log of t. But e and natural log cancel out. So it will get t times e to the t only, because you see that. So you see that this is t because natural log and e will cancel out. So what is left is just t times e to the t. That is the integrating factor. So we need to multiply both sides of this one by the integrating factor. What do you get? So you get t times e to the t dy over dt, right? Plus t times e to the t plus 1 over t, right? And then times y equals to t times e to the t. Okay, so on the left side you don't have to worry about what will that be. Both the combination of these two terms will be d over dt. So y times the integrating factor e to the t times e to the t equals to, so that is t times e to the t again. Okay guys, so if you integrate on both sides, let us integrate on both sides. You integrate, so that integral and derivative will cancel out, and what is left is y times t times e to the t equals to, this is the product rule, right? How do you use the integration by parts? It is like t, it is like u, and then dv is e to the t. Find the derivative, 1 0, right? Find the integral. Integral of this is e to the t and then e to the t again. So this is the product, positive multiplication, this is negative multiplication. So what you get is t times e to the t, okay, and then minus e to the t plus c. This is what you get. Okay guys, so how do you do that? Is you need to divide by t times e to the t to solve for y. So therefore y equals to divide by t times e to the t. If you do that, what do you get? Is that will cancel out, t times e to the t. This guy will cancel out, right? You will get 1, and then minus, divide this by t times e to the t. You will get 1 over t, right? And then plus c e to the negative t over t. This is what you get. Okay. So what will happen if, oh, by the way, we need to find out c by using the this initial condition. Okay, using y natural log of 2 equals to 1. What do you get? Plug in t equals to natural log of 2. Okay, what do you get here is 1 equals to 1 minus 1 over natural log of 2, right? Plus c times e to the negative natural log of 2 over natural log of 2. That's what you get. So what does that mean? That means 1 equals to 1 minus 1 over natural log of 2. And what happens to that? So plus c times e to the negative natural. So this natural log and e doesn't cancel because there is negative sign. You need to move that to the 2 to the negative 1, right? That is 1/2. So you get you get e to the negative natural log of 2 is same as 1/2. Okay, 1/2. Why? Because that moved to this negative, moved to 2 to the negative 1. Okay, and 2 to the negative 1 means 1/2. So e to the natural log of 1/2, e and natural log cancel out, that will be 1/2 just, and divide by natural log of 2. So what do you get for c? Let us see what you get for c. So this subtract 1, okay, subtract 1, add 1 over natural log of 2. What do you get? You get 1 and negative, that will cancel out. So add 1 over natural log of 2 equals to c times 1/2, that is 1/2 c over natural log of 2. So if you multiply both sides by natural log of 2, what do you get? You get 1 equals to c times 1/2. So what is c? C is 2. Multiply both sides by 2. Therefore, what is the final solution then? The final solution is this guy, right? With the c equals to 2. So therefore, the final solution is y of t equals to 1 minus 1 over t. And then plus 2e to the negative t. 2e to the negative t divided by t. That is the final answer for this problem. Okay. So let us do another example. I want to do example number 25 from the book. Alright, so let us see. Actually, this is example number 5. Okay, but this is question number 25 from the book. So the question is, the differential equation is ty prime plus 2y equals to sine t over t, where y at negative pi half is equals to a and t is less than 0. Okay, draw a direction field and then find out what happens to yt as t tends to 0 with changing behavior of a, the initial value. Okay, and so solve and find a. All right, and then also describe the behavior of yt. Let us first answer the first question, draw the direction field. So again, I'm going to use that app to draw the direction field. So what we need is, if you solve this for y prime, what do you get? You get y prime equals to divide by t, right? You get negative 2y over t, right? And then plus sine t over t square. That's what we need to enter in the right hand side. We need to enter in the app, right? So what we need to do here is, you need to do negative 2y over t, right? And then plus sine t over t square. That's what you are going to do. And then it says that you need to do only for the left side, right? Let's say negative 5. We don't have to do negative 5. So what is negative pi half? Because negative pi half is pi over 2, right? So negative 1.57, negative 1.57 through the 0, right? Through the 0. That's what we're going to do there. Okay, this is what you see. Okay, guys. And then for the y values, let's say that the behavior of the solution changes at this point, right? We need to know what is that point. So below that it is going down, okay, and above that it is going up. It sounds like that, right? When t tends to 0, you see that it is going that way. You see that? Look at this one. Okay, so whenever you are getting very close to that point, if your initial value is above that, it's going to positive infinity, or it grows up, and then below that it is going down. You see that? When t tends to infinity, that's what it looks like. But we need to find out that point. So what I want to do is, I want to do a little bit of work and then see, zoom in near that. Okay, so let us do negative 1 to 1. Okay, negative 1 through 1. If you do that, what do you get? You get that line is, we don't know it, right? Let's do 0 to so for the y value, let's do 0 to 1. Then you can see this look like 0.4, right? You see that? So above, if you start above 0.4, it is going up. If you start below 0.4, then it is going down, right? So what you can say for question number 1, the answer for the question number 1 is, let me, since you need to solve for negative t, right? So you need to have the space on the left side, so it is, this is t, right? And then this is 0, so let's suppose this is 1, right? This is, say, -1. And then what we saw in the so negative pi half, t is negative pi half. So what we found here is, if you take the values above that, you saw that one. If you get below that, that's what we see. That's what we see. See, if your starting value is at above 0.4, then the solution goes up, increases up and goes to infinity, and if it is below, then it goes to negative infinity. That's what it looks like. Okay, let us do that. So then what we do is, as t tends to 0, then y goes to positive infinity if y at negative pi half is less than positive infinity. Let's do negative infinity, less than 0.4, and y goes to positive infinity if y at negative pi half is greater than 0.4. That's what we can say, okay, about this. The next thing we want to do is we need to solve and find a, okay? So we need to solve it. Let us solve this. So how do I solve this? You need to write this in the form of the linear form, right? So you do, so to solve it, that's part A. Now part B is y prime plus 2 over ty equals to sine t over t square, right? That's what you get. Now what do you get for the integrating factor then? Integrating factor is e to the integral of 2 over t dt, right? So this is same as e to the 2 natural log of t, right? This is e to the natural log of t square. So natural log on e will cancel out, so the t square. So you need to multiply both sides by t square. What do you get? Is you get t square times y prime plus twice ty equals to sine t only, right? Now on the left side, it is d over dt, y times the integrating factor. The left side is always like that, the y times the integrating factor, and then on the right side there is just sine t, right? So we need to integrate on both sides. What do you get? You get, if you integrate on both sides, you will get integrate, you get y times t square equals to, what is the integral of sine t? Is negative cosine t, right? And then plus c. Let us divide by t square. You get y of t equals to negative cosine of t over t square, right? Plus c over t square. That's what you get, right? C over t square. Now we need to use the initial condition. What is the initial condition? Y at negative pi over 2 is equals to a. Let us use that. So a equals negative cosine of pi over 2 over pi square over 4, right? So it is, I think, negative, right? Negative pi over 2. And then plus c over negative pi over 2 square. So I'm plugging in a for y and then negative pi half for t, right? So what is the value of cosine negative pi over 2? It is 0, right? So what you get is c equals to pi square a over 4. So what is the solution then? So your solution, final solution, look like yt equals to negative cosine of t over t square, right? And then plus pi square a over 4t square. 4t square. That's what you get, right? Now we need to find out what happens when t tends to 0, right? So this can be written as, you can write this as, say, negative cosine of t plus pi square a over 4, and then 1 over t square is outside. You can write like this. Okay, now when t tends to 0, this goes to, then this will be positive, so this goes to positive infinity. If this quantity is less than negative 1, then this goes to negative infinity. So what you can write here is, thus y of t goes to infinity if pi square a over 4 minus 1 is positive, right? If that is positive, that means what? A is greater than, so if you add 1 on both sides, what do you get? You get a is greater than 4 over pi square. A is greater than 4 over pi square. In that case, yt goes to infinity if a is greater than 4 over pi square. Similarly, if this is negative, right, that is a is less than 4 over pi square, this goes to negative infinity. So you can write that way too. So you can write yt goes to negative infinity if that thing is negative, meaning a is less than 4 over pi square. That is the final answer. Okay, so I want to do one more problem, very last problem. Okay guys, so let me write down the question for that. So the very last problem that I'm going to do in this section is question number 31st from the book. Okay, what it says is, for the initial value problem, y prime minus 3 half y equals to 3t plus 2e to the power t. Okay, and where y0 is y sub 0, then you need to find y sub 0, find that value, that separate solution that grows positively or negatively as t tends to infinity. Okay, solution. So it didn't ask you to draw the direction field. So what I'm going to do is I'm going to solve it. So what is the integrating factor here? Because this is already in the standard form, right? There is just y prime, there is p y equals to q. So integrating factor equals to e to the integral p of t dt, right? So that is e to the negative 3 half dt integral. So how much is that? That is e to the negative 3 half t, right? That's what you get. So what you need to do is you need to multiply both sides of this equation by that. So you get e to the negative 3 half t times y prime minus 3 half y equals to e to the negative 3 half t times 3t plus 2 times e to the negative 3 half t times e to the t, right? So the left hand side you can distribute this, or you don't have to actually do that, because the left hand side is always d over the derivative of y times the integrating factor e to the negative 3 half t. That is the left side. And on the right side you have to do the integration by parts, right? How do you do that? Integration by parts there. For the integration by parts, what you need to do is you need to do, for the first one, you write, let me write down one more time. Let me copy that one more time. Okay, 3 times t e to the negative 3 half t, and then plus 2 times, what is that? E to the negative 1 half t, because they have the same base, right? You combine those two, you write e to the negative 3 half plus 1, right? That is negative 1 half, and the t is outside. So that's what you get. Now I want to use integration by parts for this. So it is like u and then dv t e to the negative 3 half t. Derivative is 1 and the next derivative is 0. The integral is e to the negative 3 half t over negative 3 half, right? That will be negative 2/3 e to the negative 3 half t. If you do that again, you will get positive 4/9 e to the negative 3 half t. So this is positive multiplication, this is negative multiplication. We are in, let us integrate on all sides. Okay, let's integrate that, and what you get is the derivative and the integral sign will cancel out, right? So what you get is that will cancel out that one. So y times e to the negative 3 half t is equals to what? Is equals to, you copy those. Okay, you get t times negative 3 half, so it will be negative 2/3 t times e to the negative 3 half t, right? And then minus 4/9, right, e to the negative 3 half t. And what is the integral of that? Minus 4. Why? Because you get integral of this will be 2 e to the negative 1 half t over negative 1 half, right? Because this is the formula, e to the ax equals to e to the ax over a. That is the formula, plus c. That is the formula. That's why. Okay, so that will become negative 4 e to the negative 1 half t plus c. That's what you get. Okay, so this is what you get. Now the next thing I want to do is I want to simplify this, okay? I want to simplify this solution by, first of all, let us divide by e to the negative 3 half on all these terms. Okay, what do you get? Then you get, let me write down here. Then you get y of t equals to negative 2/3 t, that dividing by that will cancel out, right? And then minus 4/9, that will be e to the negative 3 half t, right? And cancel with that one, negative 4/9, and then minus 4 times, you divide this by e to the negative 3 half. What happens? E to the negative 1 half t divided by e to the negative 3 half t, and then plus c, right? That's what you get. Now if you simplify that, you will get negative 2/3 t minus 4/9, right? And then minus 4 times, oh, by the way, I forgot to divide this by negative 3 half t, okay? And minus 4 e to the negative 3 half, this will move to the top. It will become e to the positive 3 half. Positive 3 half minus 1 half will be just t, e to the t. And then plus c times e to the 3 half t. So y of t equals, right? Now using y at 0 equals to y0, what do you get? You get y0 equals to, this will be 0, this will be negative 4, right? So negative 4/9 minus 4, and this will be plus c, right? Oh, by the way, I forgot something here. Let me show you that. I forgot that 3 here, okay? So this is 3 times that thing, okay? So what do you get? So 3 times that thing. So 3 times, okay? So that 3 and 3 will cancel out, and 3, so this will become 3, right? So what do you get? You get, this is negative twice t. This is negative twice t. This will be 3, right? That's what 3 look like. So 3 look like. So what do you get? You get negative 4/3. Negative 4/3 minus 4, right? And then e to the t is that term, right? So that is just 4, right? And then that's what you get. So what do you get? So negative 4/3 minus, is that a 19/3? No, 12/3, right? This is a 12/3. This is so 16/3. So y0 equals to negative 16/3. 16/3 plus c. Therefore, c is equals to, you get y0 plus 16/3. That's what you get. Okay. So now what happens when t tends to infinity? When t tends to infinity, the highest exponent pull all the solution on that in its side, right? So let me write down the final solution. Y of t equals to negative twice t minus 4/3 plus 4 e to the t plus y0 plus 16/3 e to the 3 half t. See, this term has the highest exponent, right? E to the 3 half t. So when t tends to infinity, they will grow or decay. That will happen, but this will have major effect. It will move faster. Okay. So meaning that this solution will go to positive infinity if it is greater than 0, if this quantity is greater than 0, and negative infinity if this quantity is less than 0. Okay, that's what you say. Okay, so we can, hence yt increase positively if y0 plus 16/3 is greater than 0, right? And y of t decrease if, or increase, negative means decrease, right? If y0 plus 16/3 is less than 0. That's what you do here. Okay guys, that is the end of section 2.2.